Hi, sorry. The system asked the privilege to share screen. Okay, let me try. Okay, can you see my screen?
I can see it.
Yeah, okay. So Alibaba Cloud is the biggest cloud provider in Asia, like China, Thailand, around that place. So we adapt Karpenter to that cloud provider. Okay, so let's say we have some node already, and we already launched the deployment, and we can see we use AMD 64 and Sport, and we have one instance class, is node class, and it's Alibaba Cloud Provider related things. So now we can directly scale one deployment, and it will create one node client. You see, and you can see when it's get ready. It maybe takes about 2 minutes. It's not so good, so fast as AWS. Okay, wait a minute. Okay. Wait a minute. It may be take about 2 minutes, a little bit more. Okay, now the node is created and it will be ready soon. Okay, now it's ready. As you can see, the node is created based on the node client. As you see, it selects the like Karpenter. It selects the multiple instances and then create with the lowest price, like what Karpenter AWS provider do. So when we scaled down the deployment, the load client will be deleted. Client as the expiration period here, 1 minute after, consolidate after. So that's all about my demo, actually. It create nodes, bin pack, and consolidate drift and other functions. Everything is ready. Now we just want to optimize the speed of node initialization. Okay, thanks guys. That's all my demo.
Well, that was cool. Thank you. Is this currently open source or is this
It's open source. We open it.
do you
Karpenter, wait a minute. Here, the link is here. Karpenter provider is AliCloud here. We will complete the release docs and release the first version recently. Yeah, I can copy the links in the doc.
If you can put it, yeah, add it in the document on the working Google Docs, that would be great, so other people can take a look at it.
Yeah, sure.
Thank you very much. Oh, and then,
We hold back. Okay, link. Okay. Okay.
I had a question. I was curious in your experience, like how difficult it was to build this out, integrated. Did you find, like, how long did it take you to kind of build and integrate this cloud?
Actually, it depends on the API capability of the cloud provider. Sometimes it's quite difficult because you need many workarounds to provide same capability like AWS. So actually, it really depends on the capability, underhood capability of the cloud provider. But most part, it's easy. Just like the way or how Karpenter do, AWS provider do. This one takes us about 2 months to implement for two people, with two people. Okay.
okay. Now, moving on to the next update around the GCP provider.
Yeah, that's I want to say. Recently, we want to start GCP provider, and we want to bring this to GCP. You know, GCP has one product called GKE NAP. It mostly focuses on node provisioning with stability and availability, but we Karpenter more focus on cost effective. So I want to bring this to GKE. So maybe we will give a PR about this provider next, about the provider in the rhythm of the Karpenter core lab. Okay, that's all.
Okay, that sounds good. Then let's move on to RFCs. The first one.
Yeah, this is it's our group, our team give this PR. The background you can see the background. Can you open the README file? Yeah. You can okay. It's simple. I have 10 padding pods. You can see, and the first one is one core and with 1 GB request. Okay. Yeah, this one looks better. With undefined cannot be scheduled to the same node as pod 10 and pod 9. Let's directly see the result. In Karpenter, it creates 3 nodes, one super big node and 2 much smaller node. And what we want is make this balanced, not so one very huge node and with very many small nodes. So we want this balanced like here. The pods more distributed, not so stay in one node. So in this situation, if the cluster, if one node is being terminated, like that, receive the termination signals, it will drain the node. So the less load will be influenced, be rescheduled. Yeah, like here, if you in now, if node one, the node one is terminated, there will be 8 pods will be go down, maybe rescheduled. so the service availability will be affected. But for what do you want in the expect behavior? Only 4 pods will be rescheduled. The service will be more stability, will be more stable. That's the background. So we just want to, in Karpenter, there's one sort function to make the pod to be scheduled at first with higher requirements, CPU or memory. So we want to sort this based on the resource request and the affinity or topology spread constraints, and put them first. Then this problem will be solved. Yeah.
This is the original ticket issue.
Yeah.
So just to summarize what you just said, so you're proposing that we sort the mutually exclusive pods first, schedule them first, and then schedule based on CPU memory descending? Did I get that right or
Yeah.
no? Okay.
Yeah, exactly. Because with our customers, there are always, it always create one super big node, maybe 64G, 64 cores and 128 GB, and many other small nodes, like one core, 2 GB. It's really unstable, actually.
Why is it unstable?
Because like we use spot instance now. So if the super big node is we receive the spot interruption event, so we should delete this node. Delete load time, it will go through the training process. So which means many pods will be rescheduled. If there at this time there is some like traffic peak, actually the many requests will fail.
Got it. So you're trying to reduce the blast radius of a spot interruption is effectively the use case here. Is constraining the size not enough, or like there's some reason you can't constrain the size of the options that you pick from?
Yeah, it's possible if you want to constrain the size, like the max CPU or max memory. But it need extra configuration. I think firstly, you just I see in the code of Karpenter, it tries to distribute the nodes more balanced. I see the coding in the Karpenter code. But I just want to edit the function, modify the function that how to sort these pods. Which pod should be scheduled first and secondly and thirdly, actually.
Yeah, I'm trying to think. Like it may work, maybe. Yeah, I guess the problem at the end of the day is we don't schedule the pods, right? So the kube scheduler gets to pick. So there's a bit of an interaction with the scheduling config. I get that you may not launch the large instance type, so that may prevent you from running into this scenario. But also you could because you're using Spot, and I don't know what Alibaba Cloud's decision making is on Spot. But like at least fundamentally at least I'm familiar with the AWS side. So on the AWS side, you could get the largest instance type that's put into your node claim with a Spot launch. You probably won't because it's probably the most expensive, but like the interaction between the size of the instance type and the relative availability and the cost, I guess, with that and the relative availability of that instance type might mean you still would get a large instance type. So you could still run into the same situation even if you scheduled simulating that not being the case. Although I do agree that I guess it would overall reduce the amount of time you probably see that problem. But I think fundamentally your issue is spot interruption, right? So
yeah,
guess I'm curious. So not all these pods don't necessarily all have topology spread on them to like handle that kind of scenario with like, because like how, I guess if your pods are spread across nodes, how bad is it really if there's one node that's taken out, if like that takes a replica down for each of your applications?
Sorry, can you pardon? I didn't get it.
So I guess I'm curious like how bad it
Oh,
is. You have PDBs configured and you've got maybe topology spread for all of your applications. How bad is it if you actually, like if you receive one replica down per application as a result of a spot reclaim?
actually, we are managing Karpenter service, so we provide platform to customers. Some customers didn't use any PDBs, even a little bit, and sometimes they just with very many replicas deployment, and if like this, so maybe sometimes if we schedule one all of the pods into one node, sometimes the interruption will really affect a lot, influence a lot. Like if you draining the node, all the pods will be deleted. So the service
Yeah,
will
so
stop.
I guess the counter argument to your proposal is like, what happens if those three nodes on the second section there can all schedule onto like all the pods can schedule onto one node? Do you choose one node or do you choose three balanced nodes?
Yeah, exactly.
Well, what do you choose?
Sorry, which I can choose? First
I'm
one
saying
is
if the options are one large instance type, which may make your cost cheaper, versus three instance types, which may increase your cost, and also like daemon sets have some overhead, so that's going to take away some of your capacity as well from those three nodes. Like, which do you choose?
of course the three nodes.
You choose
But
three?
yeah,
I don't think
three nodes.
everyone would choose three.
First one, maybe it's a little bit expensive, but I think the price is just a very little bit higher, very little, because the request size didn't change. So like I have one node with 3 core, and I have 3 nodes with each one is 1 core. I'm sure that the 3 nodes the price totally is just a little bit expensive than the one node with 3 core.
Yeah, I guess this is kind of like a larger, I mean, I think this is a pretty short write-up, but I think the actual scope of the design is probably extremely large because now we're talking about like fundamentally changing the scheduling assumptions about how things are scheduled, which I don't think is like off limits necessarily. I just think that it has a lot of implications in a lot of scenarios, and like it's scary to touch it without thinking through all those scenarios. Like if somebody cares more about cost than they care about like saving cost, or they have large daemon sets and they care more about like constraining the number of nodes they have in their cluster, or they have some price overhead for per node, which is I know common with some monitoring platforms. So they would favor having less nodes, and they just know that their applications are configured correctly to handle less nodes. Or they're not using Spot at all, and they're just using OD, and they just know that they can have tightly packed nodes. Like how do we handle that when it comes to making like a balanced decision? And also what does balanced mean? Like how many nodes do you need to have to consider your scheduling simulation balanced?
Mm-hmm.
It's hard to tell like what the outcome of, and it's probably because I haven't personally thought through it too much, like the outcome of like resorting the nodes is going to be, and like what that actually means in the context of like a scheduling simulation. Because with the proposal you're saying, I believe we'll still pack as many pods as we can on the first node. So that balanced assumption isn't necessarily going to happen, right? Because we're going to schedule the anti-affinity pods, the topology spread pods. That's going to give us a certain number of nodes, and then we're still going to prioritize whatever node comes first in that set.
Yeah.
Schedule a bunch
Yeah,
of pods.
exactly. Yeah. Yeah, it's hard to tell which one is the best choice. Like for AI training scenarios, yeah, it's okay to use one super big node. But like for web API, for some web services, service down is not a good idea. Actually, maybe it can be a little more expensive. Like if some service you can do like AI training, you can do checkpoint and resume from checkpoint, and it's okay. Yeah, it's hard to tell. I can say it's the only thing I can say.
Yes, I guess I'm skeptical that a resort on its own is enough. Like, I'm like, I think we should be open to talking about this because it's an interesting thought experiment. I'm just curious what actually you would propose changing on the scheduler side, because I think as stated right now, it would still pack your pods on one node if you just made the sorting thing.
It's simple. You can click. You can check the issue.
Yep.
The issue, and there is one code before in the first. Yeah, here.
Yes, yeah.
By CPU here. You see you sort the CPU by the CPU memory request. So we want to add the code to sort by first if there is affinity or anti-affinity or topology structure constraint, we will put them first. Then we put the other pods like the order here. Just put the pod first with anti-affinity or affinity or constraint. It's quite simple modification. There is one PR, you can check it. It's quite simple, very easy. The issue, yeah, here. You can see field change, it's very little bit modification.
Okay. I mean, I think Nick had probably looked at this a little bit. I can take the time to look at it as well.
Yeah.
I'm still a little skeptical, to be honest, but I can read through the code and think about how this might
Yeah,
work.
you can check it later after the meeting. You can comment anything you have suggestions. Okay.
Okay, sounds good. Let's move on to the next RFC. Yeah, Shribasti is on the call.
Yep, sorry, I was on mute. I was talking on mute. Hey guys, so this is an RFP I submitted for as a follow-up to the PR that we merged for the deprecated AMIs. And this RFC basically goes into the approach for observability in terms of how we want to do that. So there are three options that I included. Let me see if I can, my Mac allows me to share the screen, just a sec. I'm trying to see if I can share. Sorry. Just a second. Yeah, I'll have to rejoin, but so just let me try to rejoin.
Sharing my screen if that's, or if you would like to just rejoin.
Yep. All right. Hopefully you can see my screen. So this is there are three options that I outlined. Basically, one is to update the EC2 node class CRD, which kind of includes a new field in the status for the AMI struct that says deprecated or not. That gives us like a couple of pros and cons. One is it just provides an view on the status of the node class that tells us which AMI that was selected is deprecated or not. The second one is adding a new status condition, which says the reason and the type is both AMI is deprecated. So instead of AMI is ready, we can say something like along the lines of AMI is deprecated. But from the previous PR that was merged, this doesn't give users the clear, concise view of which AMI that was selected on the node class is deprecated. So the third option is basically combining the first and the second one, which what it does is it adds a new field to the status or the AMI struct, which says deprecated true, as well as adds a condition for the reason and the type saying that AMI is deprecated. The good advantage of this is, from what I read through the code, is it gives us a metric out of the box, which is the operator status condition count, which for AMI is deprecated will go up, as well as, cluster admins or users can just come in, look at the status, and then from the fields, figure out which of the two AMIs that this node class selected is deprecated, which will help users kind of, move to a newer AMI or, take any actions that are needed. So those are the three kind of options that I have. The fourth one can obviously be like we can add a message over here in terms of which AMI is selected, but then that can it makes it very difficult to read, wherein the message can be longer than expected. So that's why I didn't include that option. But that's also another option which we can include in this RFC, like if needed.
Are you trying to share your screen?
It is sharing, it's not.
I can see it.
You see it? Oh, okay. It must be me.
Looks good to me. No, no comments on my side. I think option 3 makes sense, at least from my end.
Yeah, I mean, like that's that's what my recommendation was as well, to go with option 3. It's clear, concise, and then users can just come in plus a metric out of the box as well.
I guess the only question is, you only want, I think this is right. Like you only want AMIs deprecated to appear when the AMIs that are resolved at the end of the day, like
Yes.
not just the ones that you select on, but just the ones that would actually be launched.
Yes.
Yeah. Yep.
So yeah, anyone has any questions, comments on this? Nope. Okay, cool. Thank you, everyone. So just to get an idea, so what would be the next steps from this? Like, how should I move forward?
I think we should look to, I mean, it has been reviewed, Emmanuel. I think you were looking at
Yeah,
this.
I'm looking at it. I think probably just somebody else from our team taking another look at it, and then it should be good to merge. Yeah, and then sure, if you can go ahead and then make the implementation for that, that'd be great.
Yeah, so I think just an approval probably early this week and then merge it and then move. I mean, you could start implementing it now, honestly, but at
Got
least
it.
that would be the confirmation that, it's agreed upon from the maintainer team, but I think just from talking with other folks and I don't really see if there's gonna be any kind of issue with that approach.
All right. The only thing is like there will be a CRD upgrade, so I guess that's okay, right? Like,
It's an additive change, so it's not an API version bump or anything, so it should be fine.
okay, cool. Thank you.
Hi, Jonathan. I have one last question. Do you know anyone like from Google? I mean, do they have plan to adopt Karpenter to GCP?
Depends what you mean by we. Like I think that no one is actively working on it, as far as I know. I know that there was somebody that had tried to implement GCP support like 2 to 3 years ago, and it
Mhm.
didn't get headwind because I think there were some blockers that needed to be fixed on the Google side. I'm not sure if those blockers still exist today.
Oh, okay, I get it. So actually, we are trying to connect to somebody from GCP, a developer, and we want to build them with them together. So actually, it's our situation.
It may be worth,
May-
I mean, oh, looks like Elmiko is raising his hand.
I mean, I'm probably going to suggest the same thing that you're about to say, Jonathan. But a way, you might want to come to the SIG Autoscaling meeting if you can make it earlier in the day on Monday. Because usually there's GCP maintainers there, like, Maciek Paito, who's one of the chairs for SIG Autoscaling, is a GCP maintainer. So you could go
Oh,
reach out to him.
oh, okay. That's a good idea. Okay, I have no question more.
Okay, sounds good. And then there was one other RFC that I did want us to talk about quickly about the node auto repair RFC that we have out. This is something that we're hoping to get in earlier this week, but if anybody else has any opportunities to review it and add some feedback, this is a feature that we're hoping to put under an alpha feature flag. So it's in the early stages and something that we hope in the future to roll out additional configuration service features and options around the feature. So if anybody has the opportunity, please feel free to go and review that as well. I won't go into too much detail just because we've already discussed this in a previous working group meeting. So I'll just add it into the working log, and please take a look when you all have a chance. Now, then moving on to the community questions. Does anybody have any questions that they would like answers for? Yeah, Samuel?
Uh, just one thing, I didn't add it here, but for running Karpenter on Fargate, right? I think there's a couple of things that we noticed when doing it in production. We actually had to work with AWS support quite a bit to get that to work. So the resource requirements of Karpenter while running on Fargate is quite heavy. Otherwise, it keeps on crashing constantly for a cluster with like around 200 node claims or something along those lines. So just doing it the normal way of giving Karpenter around 2 gigs and a CPU didn't actually scale as better on Fargate. So that's just something that we noticed while doing it on production, and AWS support recommended to just go higher on the resources, and it's been stable since then.
So, okay, I guess to quickly just address that, typically, depending on the scale, I mean, if you do not give Carpenter enough resources, depending on this actual scale, the pods will crash. So even, at least from my experience, even if you were to use EC2 instances, you would run into to this kind of situation if you do not give Carpenter enough like CPU to actually be able to run through the computation. If not, you will continuously crash. And if you're doing like heavy scale ups, the scheduling simulation themselves can require, if they don't have enough CPU, they themselves can take a really long time. So typically, you want to make sure that you're giving enough resources to the Carpenter instance depending on the scale. And I'm not exactly sure what the scales you're running at, but you typically have to give it. Did you see something different, at least when you were if you ran it on when you ran it on EC2 instances?
Yes. Yeah. So on EC2, just setting the resources to the minimum on the Karpenter pods themselves, it was pretty stable and it never crashed, at least in our experience. But on Fargate, what support told us was when we set the lowest possible resource limits on the Karpenter pods themselves, the Fargate underlying Fargate nodes that are selected are the least ones, like T2 micros or something like that. And that doesn't scale as much, which causes the Carpenter pods to crash. On EC2, we just went with M5 X large and gave it like the minimum resources, and it was pretty stable for the same cluster. So yeah, that's just the recommendation that was given to us. I just thought maybe that's something that can be improved in the docs, at least for the Fargate piece.
Yeah, I mean, we'll be willing to hear any feedback and additional documentation, so please feel
Yes.
free to see PR for that. Sorry. Okay, Samuel, you want to go now?
Yeah, I wanted to ask one thing that we were talking about earlier was more observability for deprecated, I guess you call them AMIs, Amazon Machine Images. So I was curious about observability for just drift of AMIs generically. So when you update your EC2 node class to a new AMI, my understanding is that today you would basically have to look at every node and look at the AMI manually and track that yourself. I was wondering, is there any sort of recommended observability in terms of drift being remediated over time, basically status checking of drift detection?
Yeah, we currently do emit metrics around the status conditions that are on the node claim. And so in this case, drifted is a status condition that's added. If you go to our documentation around metrics and look at the status condition trend, yeah, I believe here these metrics should give you the ability to be able to actually track the changes within the status condition. So you will see the amount of drifted nodes that you the drifted node claims that you have in your cluster, and be able to track that over time.
Okay, that's definitely helpful. The one other question I had, assuming that there's nothing else here, my other question was about eviction. So I know that there is disruption control where you can specify do not evict or do not disrupt, I believe it got renamed to. However, the use case that we have within Pinterest is that we have a multi-tenant cluster where we have some workloads where we want them to just evict according to the pods. Forget exactly what it is, the safety seconds that it has set for the pod. But then we have some workloads that are more like jobs, and we want them to be able to run for maybe up to 7 days. And then if they don't complete by then, go ahead and evict them or disrupt them. And my understanding is that this is sort of possible with the node level. You have the grace period you can set on the nodes, but then that ends up applying to every single node, even if one of these long running jobs isn't on that node. I was wondering if there's any sort of suggestion for that type of problem where you have a long running job that you would like to allow to naturally complete.
So I guess so then if you're saying like, I guess, have you tried different node pool configuration to allow you to at least segregate these job-based like pods versus like the long running pods? That way you'll have you'll have the ability to configure the node level disruption controls differently for those kind of applications.
Yeah, but then you're segmenting the nodes, right?
Yeah. I mean, it's like separating them out into like using different methods like labels or chains to be able, or affinities to be able to spread them out or separate them.
Yeah, so I think we are looking for something that allows us to keep all of our nodes more fungible, but still allows the disruption handling to be based upon what pods are running on the node. So this is something that we already have implemented in one of our services, and we're hoping that Karpenter could replace that functionality. But this is one of the gaps that we noticed, is that our current system, we can we can look at the node, see what's running on it, and see that it's one of these long running jobs, and then we can give it 7 days. Where if it's not, we give it like a few hours. And it seems like in order to do that in Karpenter, you have to have completely segregated nodes. And just trying to understand if there is some other way to do that.
So I think the do not disrupt annotation, have you seen that annotation? Where you can like
Yeah,
tag up.
I think the
as-
concern there is that we want it to disrupt after like 7 days or something, but not forever. Which
Yeah,
is,
so I mean, we have the combination of do not disrupt with termination grace period, so you can theoretically like configure your node pool to say, okay, this node pool, like when a node is drained from this node pool, it should be drained within a certain amount of time, while also tagging your application as saying, okay, don't block me or block me from disrupting. And then you've effectively got a scenario where you'll drain your node, those pods won't drain, they'll sit there and wait up till the grace period of the entire node and then tear the node down at that point in time.
yeah, I think my understanding of reading the docs on that feature is that that applies to every node within that node pool.
Yep.
So then we wouldn't be able to have some jobs that we want to terminate after, say, 3 days rather than 7. Like every node within that pool would have to wait the full 7 days. Because the do not disrupt is binary, and then
Yep.
the setting for the grace period is on the node itself and not on the pods running on it. So I think that's where we run into this issue.
Yes, you want like an application-based termination time.
Yeah, so I guess like one possible implementation I was thinking of is that the do not disrupt, instead of being binary true or false, you could have a time period. You could say do not disrupt it for 3 days versus 7, etc. Otherwise, it would need to be somehow more dynamic based upon what pods are running, and I'm not sure how easily implementable that would be.
Yeah, I just posted the issue on this to the chat. This is the one, I believe, where we talked about duration on top of this guy. Because we've had some more thoughts before. This has been a feature request. And I think, yeah, there's like a couple examples in here of folks adding like a duration to the do not disrupt annotation and like proposing that.
Yeah, I think this is definitely very similar to what I'm talking about. And I think they're suggesting looking at termination grace period, which is for the node at least the last comment here, and which doesn't quite solve my problem or our problem. So
Got it. So today there like is there like an annotation on these pods today that tells your custom terminator like when it should disrupt these pods?
So our system takes a look at the pods that it's running, and it's actually looking at, today we're running CRDs, custom resource definitions. So it just takes a look at what those are named. I'm not sure exactly what aspect of the spec it's looking at, but it's doing effectively, we have it configured to look at the pods and look for specific specs within it. I'm not sure at the pod level it's annotations or what, but I think it looks at the CRD level probably above that. So it has something that's more dynamically effectively saying, like, if we're running a pod of this particular annotation, sort of like what you're saying, then we apply the longer duration grace period.
Yeah, I think it makes sense. Yeah, I mean, I guess the best way forward is propose a like kind of what we've been talking about here, like propose an RFC for this feature if you think it's useful to you, describe the use cases, and link this issue. I think we've generally thought about this and think that it's a reasonable, like just off the top of my head, I think it's a reasonable approach. I'm just trying to make sure there's not any other mechanisms that exist today. It sounds like not that can solve this for you without having to build additional surface. But I don't think it's too crazy to add duration here.
It is or is not easy?
It's not, sorry. I don't think it is too crazy.
Okay, so do you want me to comment on this existing issue or create a new one and link this, you were saying?
No, I think this is the issue. I think if you're wanting to get like traction on like if you've exhausted the options inside of Karpenter and you think there's not a way to do this inside of Karpenter that exists today, which it sounds like probably not based on what you just described, then I think the next option is, propose this with an RFC inside of the repo and describe your use cases, and that's the best way to get traction on like this getting implemented, I think.
Okay. So I may start with just a comment on this issue and then talk about it internally with my team and then see if we could go about creating an RFC. Do you have a guide for RFC creation or contribution guide or anything?
I think the best, there is like a design guide. I think the best example is perhaps like abide by a similar design proposal process that exists for KEPs. We kind of try and abide by the same sort of format of describing your use cases, talking through any API service that gets added, and then walking through possibilities and solutions.
Okay. Yeah, those are the only two questions I had.
Sounds good. Any other questions? Cool. If nothing else, then we can call it. We can call this meeting to an end. Thanks everyone for joining. Hope to see you next time around in 2 weeks.
Thank you.
Thanks. Bye.